You walk into a hospital. Unbeknownst to you, an algorithm has assigned you a number. This number is your medical risk score, and it will determine how much medical care you need and how urgently you need it. This is not science fiction. Risk scoring algorithms are widely deployed in the health insurance industry. And according to recent research from Berkeley, these algorithms can systematically undervalue your risk if you're Black. Real-world bias often makes its way into the data we collect, which results in algorithms that learn and perpetuate that bias. This is an example of machine learning bias. Hi, I'm Inderpal Kaur, and I'm a graduate research assistant at the Daylight Lab. Our team has spent the past year developing hands-on educational lab materials that demonstrate examples of machine learning bias in real-world settings and teach students how to address it. The example I mentioned earlier about racial bias in healthcare, that's our first lab, based on work by Ziad Obermeyer here at Berkeley's Public Health Department. Our second lab investigates whether there is bias in a home lending company's prior decisions. And our third lab discusses gender bias in hiring and how to train a classifier to counteract this bias. Our labs are interactive notebooks containing Python code that students can run and edit for themselves. These Jupyter notebooks lay out the technical knowledge for identifying and correcting for bias. More importantly, the labs probe students to think critically about bias in context. That includes examining how we define bias and who gets to do so. A lot of people are concerned with AI safety, both from a social and ethical perspective, as well as a business and legal perspective. We know that bias is pervasive in the everyday world and that it finds its way into algorithms. But there's a difference between knowing that bias is a problem and knowing where to look for it, how to mitigate it, and most importantly, how it impacts specific communities in real-world context. Our aim is to close the gap between awareness of the problem and having the ability to do something about it. As far as we know, our labs are the first to teach students how to identify and ameliorate bias in machine learning. With our 3 labs, our goal is to help students think about bias in a rich and nuanced way and give them the tools to analyze it in their own work. Using these applied examples, we want to establish a framework that students can use to understand and solve issues of ML bias. Next semester, we'll be incorporating these labs into a mini boot camp on fairness in machine learning that we plan to introduce in the applied machine learning course at the iSchool. In the future, we hope to get these labs, or labs like them, into every undergraduate data science curriculum in the US. Thanks for listening.